essentially automatic, and we are anti-mechanic. We are the robots. We are the robots.
How will you service aircraft in the year 2000? Perhaps a mobile autonomous robot will perform part of this task. However, before any robot will service aircraft, the problem of point-to-point navigation must be solved. An aircraft servicing robot must be able to navigate on the runway, locate specific planes, identify damage, refuel the aircraft, remove and replace black boxes, and return. Similarly, the Army could benefit from an all-terrain autonomous vehicle. Its first task might simply be to provide commanders with reconnaissance information about the battlefield environment. Recently, AFIT has been investigating mobile robotics navigation problems. In '82, Captain Taylor conducted a feasibility study on robot servicing aircraft. In '83, Lieutenant Owen demonstrated environmental mapping and obstacle avoidance of a mobile robot using a Hero 1, laser barcode scanner, and ultrasonic transducers. In 1984, Captain Bert Schneider and Lieutenant Tom Clifford have embarked on the creation of what someday will become an autonomous vehicle.
The airman of the future is in training at Wright-Patterson in a class by himself. Rob Downey tells us this airman could teach his cousin in the movies a few new tricks.
Hello, my name is Mars One.
That's one small step for a robot, one giant leap for mankind.
We would like to have a robot that moves by itself, that doesn't have someone using some sort of external joystick control. You give it basic commands and it will go out and perform those commands by itself. R2-D2 is fantasy, and a mobile autonomous robot is one that is self-controlled. R2-D2 had a little man inside that moved it.
The two people inside Mars One this year are Captain Bert Schneider and Lieutenant Tom Clifford. Mars One has been an ongoing project at the Air Force Institute of Technology since 1982. A robot who thinks for itself. And although Mars One is learning to be self-controlled, right now even his voice pitch is decided by the two graduate students.
Ready.
And while Mars One may look like R2-D2, its eventual role in the Air Force will be as daring as Han Solo. Robots will refuel and service aircraft during hazardous duties such as chemical warfare. But don't expect to see robots rolling down the runway till at least the year 2000. And when Mars One reports for duty, it will probably be about the same size as a forklift. Rob Downey, TV2 Eyewitness News.
Several objectives must be met before an autonomous vehicle can be realized. Good software development capabilities are the key to successful robotics development. A mobile robotics lab and test facility is required to meet these objectives. Sensors and sensor software must be added to optimize navigation and obstacle avoidance algorithms. These and other objectives must be met in order to create an autonomous research system. The major differences between algorithms designed strictly for computational purposes and those designed for real-time robotics applications are illustrated in the following examples. Hopefully, any errors introduced by the environment or by mechanical deficiencies are bounded and predictable. Several robot-integrated operation tests were conducted on Mars 1 in a test range the size of a large room, 13 feet by 22 feet. Mars 1 was run in an open-loop mode through an empty room as well as a room filled with 2 objects. All test data was time-tagged and synchronized with an IRIG-B timer on both the video channel and audio channel 2. The end result of the cumulated optical shaft encoder wheel readings and the ultrasonic range and direction readings is a graphics representation of the test range, as you see now. This display is generated by a mapping algorithm during post-mission processing of the test data. This algorithm will eventually be part of the many onboard software packages of Mars 1. Power supply problems during the test severely attenuated the effective detection range of several ultrasonic transducers. You can see this result in the spurious readings throughout the test range. Other tests were run on Mars 1, varying the pattern of movement, the number of objects in the room, as well as how many sonars fired during a particular period. just a thesis and was made possible with the help of several individuals.